Some of the most brilliant biological structures on Earth share one fatal trait. They are phantoms. The rarest survivors on the planet share one fatal trait. The moment we try to put them in a cage, they die. We simply cannot build a box that holds them. Pelagic Thresher Shark. This organism engineered its elongated caudal fin into a biological whip, designed to snap with enough force to stun prey in the boundless ocean. The hunting reflex demands vast, unobstructed vectors. Confined to a tank, the tail repeatedly strikes the rigid walls during every attempted turn. The repetitive trauma shatters cartilage and induces fatal necrosis. The geometry of a finite container suffocates the energy. Later, we will descend into the lightless zones to examine an abyssal predator whose very skeleton dissolves without the crushing weight of the deep ocean. But first, we must look at an organism that functions as a massive geological processor. Gray whale. How does a planetary-scale architecture survive when reduced to a stagnant puddle? The gray whale is utilizing low-frequency vocalizations to navigate planetary migration loops. A concrete pool offers zero journey and zero acoustic absorption. The tank walls reflect every sonar click and vocalization, creating an endless hall of mirrors. The animal suffers immediate sensory overload and psychological degradation caused by a continuous feedback loop. Pink fairy armadillo. We find a similar systemic collapse in the subterranean world. Here, the killer is the absence of friction. Beneath the dry sands of Argentina, a biological thermal engine operates on a razor-thin margin of survival. Its internal thermoregulation and metabolism are intrinsically locked to the specific physical compression of native soil. A terrarium lacks this granular resistance. Bereft of its precise physical anchor, the nervous system short-circuits. The metabolism redlines. It essentially vibrates itself to death at a cellular level. It dies from environmental undercomplexity. Mountain gorilla. How does the very air we breathe become a biological weapon? The high-altitude cloud forests of the Virunga Mountains act as a natural biological quarantine. Mountain gorillas share over 98% of our genetic architecture. This makes their cellular receptors a flawless match for human pathogens. Yet they completely lack our generational immunity. A captive environment transforms into a biohazard zone. A simple human rhinovirus translates into a rapid, lethal respiratory plague. We cannot keep them safely behind glass because we cannot sterilize the air of our own biological footprint. To protect this architecture, we must remain entirely absent. Leatherback Sea Turtle. The open sea contains no walls. Over 50 million years, this marine navigator developed a sensory array flawlessly locked to global magnetic fields. Its navigation completely omits the physical concept of a solid boundary. It possesses no evolutionary reverse gear and no instinct to halt. In a concrete basin, the brain simply cannot process the glass. It swims forward constantly, striking the tank walls until friction erodes the leathery skin of its flippers, and is often followed by bacterial infection. Saola. The Annamite range conceals a biological ghost completely intolerant of confinement. The Saola, also called Asian unicorn, suffers from extreme capture myopathy. The sudden restriction of its flight distance acts as a catastrophic physiological trigger. Its nervous system violently floods the bloodstream with catecholamines. This initiates a chemical chain reaction that literally dissolves the heart muscle tissue from the inside out within hours. The sheer terror of a boundary weaponizes its own neurology. It is an evolutionary phantom so biologically fragile, it cannot exist in the same space as modern civilization. Before we descend into the abyssal trenches to examine a deep-sea predator that suffocates on pure oxygen, we must look at a breakdown of chemical architecture. Leopard seal. The leopard seal functions as an apex predator, permanently tethered to the Antarctic ice shelf. Its thermal regulation and predatory loop demand sub-zero temperatures and the freezing isolation of pack ice. In any artificial environment, the thermal baseline remains universally too high. The organism suffers chronic metabolic stress. Deprived of its massive hunting grounds, the high-drive predatory mechanics misfire. This severe spatial and thermal isolation triggers extreme aggression. The seal destroys itself trying to execute a biological program that the tank makes physically impossible. Indri. How does a highly specialized primate turn a toxic botanical pharmacy into an absolute requirement for life? Deep in the Madagascan rainforest, the Indri exists in an uncompromising symbiosis. It survives on an excruciatingly specific diet of toxic leaves found only in localized patches of the habitat. Its digestive tract is perfectly adapted and neutralizes native plant toxins. When placed in captivity, facilities inevitably substitute this intake with standard primate diets. The result is total system failure. Without the exact daily rotation of over 30 specific chemical inputs, the gut bacteria die off. It suffers massive gastrointestinal collapse. Blue Glaucus. Up at the absolute top of the water column, the blue Glaucus treats the surface tension of the open sea as solid ground. Drifting upside down, it utilizes a gas bubble to anchor itself to the sky. It is hunting the venomous tentacles of the Portuguese man-o-war. Placed in a tank with filtration currents, it can't survive. The microscopic physical boundary of the surface tension is ripped apart by the pumps. The organism sinks into the pool water and drowns. Besides that, it is also hard to supply enough extremely venomous tentacles. Vampire squid. How does a biological engine built for the abyss suffocate on pure oxygen? Down in the oceanic oxygen minimum zone, the parameters of survival are inverted. The vampire squid operates flawlessly where standard marine life instantly suffocates. Its metabolism has a highly specialized blood protein to bind microscopic traces of oxygen suspended in the freezing abyss. Brought into a highly oxygenated aquarium, the water itself will become corrosive. The sudden influx of oxygen induces severe oxidative stress. It is a biological engine explicitly built to run on fumes. Flooding its system with pure oxygen literally burns out its cellular membranes. The safety of a clean tank acts as a fatal toxic shock. Giant squid. Descending deeper into the lightless zones reveals an organism whose entire existence relies on a relentless physical weight. The giant squid regulates its buoyancy through an ammonia-based solution woven into its muscular architecture, flawlessly calibrated for abyssal pressure. Forcing this invertebrate to the surface initiates immediate, catastrophic tissue decompression. Its deep-sea proteins are structured to function only under extreme hydrostatic pressure. In a tank, these proteins lose their shape, effectively melting the squid's nervous system. The crushing weight of the ocean column acts as its external skeleton. Moose. It possesses a highly specialized fermentation chamber in its stomach, which relies on seasonal, extremely fibrous twigs and bark. Zoo diets almost always lead to chronic diarrhea, wasting syndrome, and systemic collapse.